You all know that today onwards we are going to focus on the science. So already we have come across one chapter, even we have finished one chapter in physics as well. But in today's class, we are going to focus on another branch of science, that is chemistry. Dear students, when we hear the word chemistry, what are the things you can recall? Just go for recalling all those. Obviously, when we hear the word chemistry, first we think about chemicals. Then we think about chemical reactions. We think about atoms, molecules. Is it not? So even not only that, even compounds, because you have already learned many concepts in chemistry in your previous classes. Then if so, could you tell what you have understood about chemistry? Anybody want to tell what is chemistry? Prashant sir, you can unmute everybody. Prashant sir. Prashant sir. Okay. Dear students, we know that we will get a lot of information about anything what we see around us, and we call this information as a science. So even we have defined the science as a systematic study of knowledge, which knowledge means getting the information about the things what we see around us, what we experience. All these belong to science only. And in science, we have divided this into three branches: physics, chemistry, and biology. In all these, we will discuss about matter only, but the way we go for describing the matter is different from one branch to another branch. See, in case of physics, we come across a matter where we study about it regarding matter and energy and the relationship between these two. In case of biology, we will discuss the matter as a matter by classifying them as living and non-living organisms, or living and non-living things. But what about in chemistry? Yes, now let us come to know what is chemistry. Before that, as I said, in chemistry also, we will discuss about a matter. Then what is a matter? What you have understood about matter in your previous classes? Just to recall it. Now I am having a marker pen. This marker pen, it has its own mass and it can occupy some space also. Is it not? Is it possible to place another object in place of this marker pen at a time? It is not possible, right? Because it has acquired its own space. So anything that has mass and occupies space, we call that as a matter. So this marker is also a matter. So like this, you can take many examples for the matter, but as we are going to discuss about chemistry, hence I'm going to show you some of the matter. You just observe them and tell what are these. See, here I'm showing one matter. Of course, you can say that it is duster, and this duster is made up of wood. Wood is a matter. Then here, a beaker containing water. Water is also a matter, right? Then here we have a water bottle, but this is empty water bottle. Then could you tell what is there inside it? Air is there, right? Look here I have shown the matter: wood as solid, water as liquid, then here empty space inside the bottle, that is air, which is a mixture of many gases. Now I'm going to take any one of these three matter. I take this as water. Just we have defined the matter as anything that has mass and occupies space, right? Example for that, many are there. I am going to take the matter called water. Yes, students, then what are the things we can go for describing about the matter called water? Yeah, you can tell about many things. You may tell about its taste, and you may tell about its color, and you may tell about its behavior when it reacts with other, or when it reacts with other matter, or else when it is mixed with other matter. Is it not? You will also tell about what it is made up of. So now just we shall go for recalling some of the points with respect to this matter, that is water. Okay, you all know that water, it's a compound, it's a matter, and this matter is made up of two other matters. Could you tell what are these? One is hydrogen and second one is oxygen. And we say that hydrogen and oxygen, they are the ingredients present in water. It is nothing but they are the composition of water. Here are right. Composition of water, it consists of two atoms of hydrogen and one atom of oxygen. It is its composition. Then other than this, what you can go for describing? Even you can describe about its structure. And when we think about the structure of water, obviously we will think about drop of water like this, right? Then its structure will be like this. Here, two atoms of hydrogen are attached with or linked with one atom of oxygen. This is the structure of water. And we also know that the water, its properties can be described without changing its identity, even by changing its identity. Just to recall some of the properties of water, you all know that it is colorless, it is tasteless. Then you know that it can boil with a temperature of 100 degrees Celsius. In all these cases, whether a matter, that is, whether water changes its identity, no, water will be water only. So then what do you call the properties which describe about a matter without changing its identity? They are called physical properties. You have learned about physical properties about matter in your previous classes, is it not? Yes or no? Once I repeat, physical properties are, these are the properties of a matter which can describe the matter without changing its identity. We can describe about the properties of water. Not only the physical properties, even some other properties which describe about a matter by changing its identity. Example, what will happen when water reacts with sodium metal? We know that sodium metal undergoes vigorous reaction. The reaction between water and sodium and takes vigorous reaction and produces hydrogen gas. In this case, whether water changes its identity after the reaction, will you identify this is the water, this is the particular water? No, is it not? So here it has lost its identity. When it reacts with some other substances or some other matter like copper sulfate, iron sulfate, here also it loses its identity. When water reacts with copper sulfate, it produces a solution called copper sulfate solution. There it loses its identity. So the properties which describe about a matter by losing its identity, they are called chemical properties, right? So we can describe about physical properties as well as chemical properties of matter. Not only this, even we can describe its behavior, and we can also describe about the changes it undergoes when react with, or when it comes in contact with other matter, right? So in your previous classes only, you have learned about the different types of changes. What do you say about those changes in which no new substance is formed? What do you call those? Yes, they are physical changes. Look at here. I'm going to take a small piece of paper. I'm going to crumple it. After crumpling, let me go for opening it up. Yeah. Whether any new substance is formed? No, no new substance is formed. Hence, it is just crumpling a piece of paper. It is an example for physical change. Those changes in which no new substance is formed. If I go for cutting this piece of wood, will it changes into any other matter? Huh? Does it change into any other matter? Iga ee wood piece na nan cut madidre wood piece irodu enadru iron agutta, wood piece irodu enadru bere matter agutta? No. So cutting of the wood is also an example for physical change. Now here again I'll take a piece of paper. Now I'm going to burn it. See that? Now the paper is burning. By burning, you will also come to know that it is producing the ash, right? Now, I'm going to collect the ash. See, by burning of the paper, now it has converted it to ash. Using this ash, is it possible to get back a piece of paper? No, because it has gone permanent change. Here, new substance is formed, and we call this change as chemical change. Those changes in which new substance is formed with new properties is known as chemical change. Similarly, even water, it can undergo those changes. What will happen to the water when its temperature is reduced to 0 degrees Celsius? What happens? What happens? It turned to ice. Will it lose its identity? No, just it has converted from liquid to solid only, but it does not lose its identity, and there will be no new substance is formed. Hence, conversion of the matter from water to ice is a physical quantity. Whereas when it reacts with sodium metal, it produces the new substance called sodium hydroxide with the liberation of hydrogen, is it not? There it undergoes permanent change. So reaction of water with sodium metal is a permanent change, which is nothing but chemical change, right? So there are two types of changes with respect to matter. One is physical change, second one is chemical change. Okay, just we took one matter. With respect to that matter, we are describing many things. We describe about its composition, we describe about its structure, we describe about its properties. In addition to that, the changes it undergoes when it comes in contact with or when it reacts with other matter. So all these are to be discussed in a branch of science, which we call that as chemistry. Got it? Have you understood about chemistry? Huh? Chemistry is a branch of science. Chemistry is a branch of science which deals with, which studies about a matter, including its composition, structure, properties and the changes it undergoes when it reacts with other matter is known as chemistry. Please do remember the definition. General information I've already told in the beginning. Chemistry means we just recalling many things. It may be about the chemical compounds, chemicals, chemical reactions, atoms, molecules, ions, like this. But other than this, if you come across the particular definition for chemistry, you can go for using this. Got it? And even you might have noticed that when we learn the concepts in chemistry, after 2 to 3 days only, there is a chance of evaporating those concepts. Is it not? ನಮಗೆ ಆ ಟೈಮಲ್ಲಿ ಕಲ್ತಿದ್ವಿ ಅಂತ ಅನ್ಸುತ್ತೆ, ಬಟ್ ಒಂದು 2 to 3 days ಆದ್ಮೇಲೆ ಮರ್ತೋಗುತ್ತೆ. Why it happens so? It is the lack of recalling one thing and lack of having the basic knowledge. Yes, students, hence first we shall go for focusing on the basics of chemistry. In today's class, I'll focus on basics of chemistry. Don't write the name of the first chapter. Instead, write basics of chemistry. Right? Go on writing with me. Basics of chemistry. It should be made. Basics of chemistry. First, let me give you the definition of chemistry. Right? Chemistry. It is the branch of science. The branch of science which deals with matter, including its composition, structure, properties, and changes it undergoes when reacts with other matter is called or is known as what? Chemistry. Just below that, you may go for writing matter. Write matter, and beside that you take some examples. It is air, water, wood, iron, etc. They're all matter. In that, write the side heading describing a matter. Describing a matter. Right. So for that, you have to take an example, that is water. Describing a matter, that take water, and below that, write its composition. Composition of water are 2 atoms of hydrogen and 1 atom of oxygen. Then, right, another point with respect to water, we can describe about its structure. Right, structure. You can copy the same. Next, properties. Next point is properties. You know that. What are the properties? Yeah, the properties will describe about a matter by changing its identity or without changing its identity. Hence, we have classified the properties as physical and chemical. Physical properties and chemical properties. Next, changes, right? Physical change and chemical change. Okay. Listen. I think I have already given you the information regarding the chapters what we go for discussing in this academic year in chemistry, right? Is it not? Total, there are 5 chapters. The very first one is chemical reactions and equations. Second one is acids, bases, and salts. Third one is metals and non-metals. Fourth one is carbon and its compounds. And fifth one is periodic classification of elements. So you had written the names of all these chapters in the very first class only. Right? Now, let's come across some of the basic terms in chemistry. Dear students, so far we described about a matter that is water. Now I go for taking some more matters like just observe, like iron, which is used for many purposes, even constructing the buildings as well. And we will go for using copper and aluminum as for domestic wiring. Is it not? Then AU means Aram, nothing but gold. Then AG, it is argentum, nothing but silver, which are used as ornamental metals. And we use oxygen for breathing. And in our atmosphere, we have carbon dioxide. And when you burn anything, at last we get as which consists of the carbon. And to give a long life to the bulb, we will go for filling it with nitrogen. Is it not? Observe, like the matter water, even I have taken some more matter. And observing all these matters, you will come to know that each of these matter is made up of very tiny particles, right? Then what do you call these particles? Means, look, once I repeat. Yes, students, you all know that these are also matter. When we consider each of these matter, they are made up of very tiny particles. And if you go for taking the iron, a piece of iron, this piece of iron is made up of number of small particles, very small particles. So then what do you call these particles? Yes, these particles are, these are atoms. These are all atoms. And we say that atoms are the building blocks of an element. Then what are the elements? Here whatever the examples I have given for matter, all these are elements only. Then what is an element? Anybody want to recall? Element. See, if you go for considering iron as an element, it is made up of only one kind of atoms, that is iron atom. When you consider copper, when you take a piece of copper, this is made up of plenty of copper atoms only. Means each of these matter is made up of its particular atoms. So any matter which is made up of only one kind of elements, only one kind of atoms is called an element. Once I repeat, A matter which is made up of only one kind of atoms. A matter which is made up of only one kind of atom is called an element. Do you know the scientist who used the word of element for the first time is Robert Boyle, right? You have already got this information in 9th standard only. Okay. And dear students, what are the elements and total how many elements are there and how many elements are known to us? You have got information about all this in your previous classes itself, right? Could you tell total how many elements are there? There are 118 elements. 118 elements. And among these, 115 elements are known to us. At present, we know 115 elements. And remaining 3 elements, already we know their properties, but still they have yet to be discovered. And these elements have been divided into 2 parts. As one is naturally occurring elements and another one is the elements which are prepared in the laboratory. They are called artificial elements, also called man-made elements. Then could you tell how many natural elements are there? Just recall that there are 92 natural elements are there. Remaining 26 are man-made elements. Again, among these, we have divided these into metals, non-metals, and metalloids. Do you know how many metals are there and how many non-metals are there? But in general, when you do not consider the metalloids, we have total 22 non-metals are there. 22 non-metals are there. And the rest of metals around 96. And in these, even some are metalloids are also there. Few are metalloids. Dear students, you are very familiar with some of the elements whose name should be known and also their symbols. Particularly, the first 20 elements names must be known. So, just we shall go for recalling the names of the first 20 elements. The very first one is hydrogen. Second one is helium. Third one is beryllium. Fourth one, boron. Third one is lithium. Fourth one is beryllium. Fifth one is boron. Sixth one, carbon. Seventh one, nitrogen. Eighth one, oxygen. Ninth one, fluorine. 10th one, neon. 11th one, sodium. 12th one, magnesium. 13th one, aluminium. 14th one, silicon. 15th one, phosphorus. 16th one, sulfur. 17th one, chlorine. 18th one, argon. 19th one, potassium. And 20th one is calcium. Right? Do you remember them or not? Yes or no? Yes. You had learned, but now you are recalling them. Dear students. So it comes under the basics of chemistry. You must be aware of these minimum number of elements. So in just go for writing the side heading element, and below that you'll go for listing these 20 elements. And you have to write the names of the elements one below the other. That's reason. Write with it. Elements, and below that you write name of the element. element. And second column, just write its atomic symbol. Atomic symbol. Yeah, please go on writing. Name of the element. The very first element is, it is hydrogen. Don't be lagging, please go on writing with me. First one is hydrogen. You know that its atomic symbol, what it is? Prashant sir?
Yes, sir.
Okay. Right. Hope that you have unmuted everybody. Or else except a few, you can give chance to a few students. Observe. Hydrogen, its atomic symbol is just H, capital H. Second one, helium. Helium, atomic symbol is He, capital H, small e. You can helium should be avoided. Helium. Third one, lithium. 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 Its atomic symbol is Li. Next, fourth one, it is beryllium. Beryllium, and atomic symbol is Be. Fifth one, this is boron. Atomic symbol is B. Sixth one, this is carbon. Its atomic symbol is, this is C. Seventh one, this is nitrogen. Nitrogen, its atomic symbol is only N, capital N. Next, eighth one, this is oxygen. Atomic symbol is just O, capital O. Here, right? Ninth one is, it is fluorine. Right. Ninth one, this is fluorine. And atomic symbol is only M. 10th one, this is argon. Neon. Atomic symbol is Ne. 11th one, this is sodium. Sodium. Atomic symbol is Na. We know that sodium, its atomic symbol has been taken from the Latin name. What is that Latin name of sodium? It is natrium. 12th one, this is magnesium. Magnesium, its atomic symbol is Mg, capital M, small g. Next, 13th one, this is aluminium. Aluminium, atomic symbol is Al, capital A, small l. 14th one, this is silicon. Atomic symbol is Si. 15th one is, it is phosphorus. And atomic symbol is capital P. 16th one, this is sulfur. Atomic symbol is S, capital S. 17th one, This is chlorine. Atomic symbol, capital C, small l. 18th one. This is argon. Argon. And atomic symbol is Ar. 19th one. It is potassium. Potassium. Atomic symbol. This is K. You know that even the letter K has been taken from the Latin name of potassium, that is kalium. 20th one. It is calcium. Atomic symbol is Ca. Dear students, other than this, even we should also come to know some other metals, some other elements which we use commonly. So let me go for giving you those. Now this time, I'll give you the symbols. You try to recall the name of these. What is that? Cr. Cr is, it is chromium, right? Chromium. Next, Mn. This is the symbol of manganese. Manganese. Another one. Fe. What is this? Fe. Its name is ferrum. Ferrum is the Latin name of which element? It is iron. Then Ni is nickel. Nickel. Then 24. It is Cu. It is the symbol of cuprum. Cuprum is the Latin name of the element called copper. Next, Zn. This is zinc. Zn is zinc. Next one, 26. It is Br, which is bromine. Bromine. Then Ba, it is barium. Barium. Next, Ag. This is argentum, is the Latin name of silver. Silver. Next, I think this much is enough. 28. Dear students, listen to me. I've given you the first 20 elements in the order, and remaining elements are given only for remembering. Got it? So these are the elements which we come across in this academic year. I've written the most possible elements which we come across in this academic year. Please do remember them. Okay. As I said, each of these is made up of single type of particles or very minute particles called atoms. So then how do you go for defining an atom? Then what is its structure? Just we should recall the information about it. Atom is, it is the smallest particle of a matter or smallest particle of an element which can take part in the chemical reaction. Dear students, please listen to me. As I said, each of these elements is made up of single kind of particles, and these particles are called atoms. Hence, we define the atoms as the smallest particles of an element which can take part in the chemical reaction. Here, even you are also very familiar with the structure of an atom. Let me go for giving you that structure. Now you may write the side heading atom. Right, side heading atom. Once I repeat, the smallest particle of an element which can take part in the chemical reaction is called an atom. So iron is made up of iron atoms only. Chlorine is made up of chlorine atoms only. Similarly, whatever the metal or any element can be taken, they are made up of their respective atoms only. Follow? So now let me give you the structure of the atom. Right. Structure of atom. Dear students, you all know that when element is taken and when it is divided into number of parts, at last we get a part, very tiny part, we call that as atom. So element can be divided like that. Is it possible to divide an atom? Is it possible to divide an atom? Of course it is possible, which you have already learned in your previous class. So, and therefore, even this atom also consists of some number of particles. And these particles are called subatomic particles, or the basic particles of an atom. Then what are these basic particles? These basic particles are protons, electrons, and neutron. Every atom consists of these three particles: protons, electrons, and neutrons. So, before going to structure of an atom, just I mentioned the basic particles of an atom. They are protons, electrons, and neutrons. See that I have written it as a code. That is pen. Protons, electrons, and neutrons. Even you have learned about the position of these particles in an atom, right? Here, just look here. Observe the word. Sound over. Observe. Think that this is an atom. It is an atom, and you all know that where the entire mass of an atom is concentrated. That is 99% of mass of an atom is concentrated. Where it is? It is in the central part of an atom, and we call this central part as nucleus. Once I repeat, the central part of an atom where 99% of mass of an atom is concentrated is called nucleus. This is the nucleus of an atom. And in this nucleus, there will be two particles. These particles are, one is proton and second one is neutron. The position of protons and neutron is in the central part called nucleus. Whereas the electrons will revolve around the nucleus in different orbits. All right, it is the position of an electron. And these two are protons and this is neutron. What is the common name that we use for protons and neutrons? Yes, could you recall? The common name that we use for protons and neutrons. They are together called nucleons. Followed or not? Gottide alva nimage? Yes or no? See, for liquid and gases, you will go for using the word called fluids. Fluids anta use martiri alva. In the same way, here also for protons and neutrons, we have given a common name. That common name is nucleons. Nucleus means they may be either protons or neutrons. So now let me go for showing you the structure of the atom. Here I have drawn it. Just please observe this. Look here. You'll come to know that here the protons are represented with red color. We know that protons are positively charged particles, and neutrons, they are electrically neutral. They do not have any charge. They are represented with black color, and the electrons will be revolving around the nucleus in different orbits. Here I have shown two paths. See, this is first one path in which electrons are moving, and this is second path in which electrons are moving. These are called energy levels, or also called shells. Got it? So this is the structure of an atom. Followed? Yes or no? Dear students, now you all may be thinking that how can we come to know that you all may be thinking that how can we come to know the number of protons, the number of electrons, and number of neutrons present in an atom of the element that you have already discussed in your previous class as well. Is it not?
Electric configuration.
Listen. You all know that the number of protons present in the nucleus of an atom represents its atomic number. Even don't write. Look here. If I write the sodium, its atomic number is 11. There are 11 protons in the nucleus of sodium atom. There are 11 protons in the nucleus of sodium atom. And we know that an atom, in general, an atom is neutral. Whole atom is neutral. What is the reason for this? The reason is in every atom, there will be equal number of protons and neutrons. Protons estiruto, neutrons kuda ashte irutte. So if 11 protons are there in sodium atom means there will be 11 electrons as well. Right? Even the total number of nucleons, nothing but protons and neutrons, it is called atomic mass number. And the atomic mass number is denoted by the symbol called, it is A. NP, do you all remember? Yes. And in general, the atom, the nucleus of an atom is denoted by the symbol X, Z, A, right? Here, X represents the nucleus of an atom, Z represents the atomic number, which gives us information about the number of protons and number of protons and number of electrons. Then A represents its atomic mass number. This mass number will also give us information about number of neutrons as well. Example, I take the sodium one, sodium thought, Na11. What is the meaning of this? It means in sodium atom, there will be 11 protons. Then number of electrons, that is also 11. But what about the number of neutrons? Neutron says it is
12, sir.
mass number minus atomic number. 23 minus 11, it is 12. Right? This you have already got in your previous class. Just write some more terms. That is atomic number. Atomic number is denoted by the symbol Z. I won't give you the definition. Then just information. Atomic number means the number of protons present in the nucleus of an atom of the element. The number of protons present in the nucleus of an atom of the element is called atomic number. This atomic number will give us information about how many protons are there and how many electrons are there in the atom. Next, second one, atomic mass number. Atomic mass number. It is denoted as A. Atomic mass number is means the total number of nucleons. The total number of nucleons, nothing but total number of protons and neutrons present in the nucleus of an atom is called atomic mass number. Next, nucleus of an atom. Nucleus of an atom, in general, as I said, it is denoted by the symbol X, Z, A. X, Z, A. And you may take the example. Example, that is sodium atom. Sodium atom. Sodium atom. And you may write its symbol. Symbol of sodium nucleus. That is Na1123. Na1123. Then the positively charged particle with unit mass, which is called protons. So number of protons present in sodium atom is 11. We write that. And the negatively charged particle with negligible mass is called an electron. So number of electrons present in sodium atom is, that is also 11. Next, an electrically neutral atom with unit mass. It is neutron. Number of neutrons in sodium atom is 23 minus 1, that is 12. Have you written? Okay. Now just we should focus on electrons. ಯಾಕೆ ನಾವು electrons ಗೆ ಬಹಳ focus ಮಾಡ್ತೀವಿ? Because these are responsible for making an atom to undergo chemical reaction. And another reason is these electrons may escape from the atom and even they may attract electrons from the other atom. Hangagi, we will go for focusing on electrons. Once I repeat, the negatively charged particle with negligible mass, they are called electrons. Then how these, as I said, electrons are revolving around the nucleus in different orbits. Now generally 3-dimensional ತೋರಿಸೋದಾದ್ರೆ, okay, this is the nucleus of an atom. It is an orbit or a path of an electron. This is path of another electron, third electron, fourth, like this. ಈ ರೀತಿ ಇರುತ್ತೆ. But how these electrons will be arranged in the nucleus? So this arrangement can be known by using a concept called
Electronic configuration.
Electronic configuration. The arrangement of electrons in the various shells of an atom of the element. is called electronic configuration. You are understanding? My simple question. Even you one the atom content, in that plenty of electrons will be there.
Yes, sir.
But whether these electrons will be having the same energy or different? Same or different?
They're different.
Same.
Different.
Different.
Same.
Okay.
Depends on the
Different.
cells.
They'll obtain the position in the atom at different energy levels. ಯಾವ್ಯಾವ್ದಕ್ಕೆ ಎಷ್ಟೆಷ್ಟು ಎನರ್ಜಿ ಇರುತ್ತೋ it will be revolving in that particular energy level, which is called shell. Got it? So electronic configuration, it is the arrangement of electrons in the various shells of an atom of the element. The arrangement of electrons in the various shells of an atom of the element is called electronic configuration. Electronic configuration. Here I'll go for taking an example of sodium. If I take sodium metal, it consists of the sodium atom and below that atomic sodium element is 11. Additionally, there will be total 11 electrons. Now let us come to know how these 11 electrons are arranged around the nucleus of an atom of the element. Here you can also write with me. This is the nucleus of sodium atom. This is nucleus. Next, I'll write the first energy level. Nothing but the first shell, it has a capacity to hold only 2 electrons. 2 electrons. I'll write 2 electrons. Yes, students, we all know that sodium has total 11 electrons. Only 11 electrons in it. 2 electrons first shell remaining 9 electrons. Again, these electrons are distributed in some other shells. Here I'll write second shell. And we all know that the capacity of the second shell is
8 electrons.
8. Andre, it can hold only 8 electrons. 8 electrons. ಮತ್ತೆ ಅದರಲ್ಲಿ ಮತ್ತೆ ಸಬ್ ಶೆಲ್ಸ್ ಇರುತ್ತೆ. ನೀವು ಅದನ್ನ ಪ್ರೀವಿಯಸ್ ಕ್ಲಾಸ್ ಅಲ್ಲೇ ಕಲ್ತಿದ್ರಿ. SPDF. Okay, ಅದು ಬಿಟ್ಟು just capacity of the second shell is 8 electrons. So here I'll write 2, then 4, here 6, then 8. Total 8 electrons. Now you count all together. Here 2, and in the second shell 8 plus 2, 10. But total 11 electrons are there. So the 11th electron in the last orbit. This is the last orbit. Here 1 electron will be there. Got it? This is the arrangement of electrons in the sodium atom. In the first orbit, 2 electrons. Second orbit, 8 electrons. Third orbit, only 1 electron. What do you say about the number of electrons in the outermost orbit?
1, sir. 8. The valence.
Here it is only 1, and we call these electrons as
Valence electrons.
valence
electrons.
outermost orbit ಅಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತಲ್ಲ ಅದಿಷ್ಟನ್ನು ನಾವು valence electrons ಅಂತ ಕರೀತೀವಿ. So here there is only 1 electron. This is valence electron. These valence electrons are much responsible for making an atom for undergoing chemical reaction. Just next one you just observe. Go for taking chlorine. Chlorine atom. Look here.
17, sir.
Its atomic number is 17. 17 electrons will be there in the atom of chlorine. And electrons are arranged like this. In the first orbit, 2 electrons, second orbit, 8 electrons, and the third orbit,
7.
2, 4, 6, 7. First orbit, 2 electrons, second orbit, 8, third orbit, 7. Altogether it is 17. 17 electrons are arranged like this. Here, the valence shell, nothing but the outermost shell of an atom of the element. It is valence shell. And observe the number of electrons in the outermost orbit. 7 are there.
7 electrons.
Valence electrons is 7.
7.
Once I repeat, the number of electrons in the outermost orbit of an atom of the element is valence electrons. Valence electrons of sodium is 1, chlorine is 7. Okay, students, you all may be thinking that why an atom undergoes chemical reaction. Chemical reaction, why it will take part in the chemical reaction? The reason for this is to attain the stability. We know that most of the atoms are not stable. To attain the stability, they'll go for undergoing chemical reaction. To attain the stability, there are 3 possibilities. One is an atom attains the stability by losing the electrons, or gaining the electrons, or sharing the electrons. But these are the 3 ways an atom attains the stability. One is by donating, second one by receiving, third one sharing. But how can we decide whether an atom donates the electron, receives the electrons, or share the electron? It all depends on the number of electrons in the outermost orbit. Now we are discussing about the stability of an atom. If you want to call an atom stable, it must consist of 8 electrons in the outermost orbit. An atom only, one orbital 8 electrons ittu andre, then we can say that stable. So, and we call that as, if an atom has 8 such electrons, then we can call that as stable atom. And that configuration is known as stable electronic configuration or octet electronic configuration. Example tolodandre, I'll go for taking argon. We know that atomic number is 18. First orbital 2 electrons. First shell there will be 2 electrons. Second shell there will be 8 electrons. Third again 8 electrons. Right? Observe in the outermost orbit, how many electrons are there? There are 8 electrons. 8 electrons, it does not go for donating, receiving, or sharing. So we can say that it is stable. Got it? Whereas, come across the sodium and chlorine. In case there is only one valence electron. One valence electron, then it needs 7 more electrons. But sodium doesn't have a capacity to hold 7 received electrons. 7 electrons are bare atom in the thorn. Capacity irolla. So that is why what it can do is it can lose the electron. Observe. Here, in case of sodium atom, there is only 1 electron in the outermost orbit. To attain the stability, it needs 7 more electrons, but it doesn't have a capacity to receive 7 electrons. Hence, it attains the stability by losing 1 electron. 1 electron in a it becomes stable. The reason is in the outermost orbit, there will be 8 electrons. Here, just write side heading, stability of an atom. Stability of an atom. Stability of an atom. Here I'll go for, I'll go for taking sodium atom. Sodium atom, its atomic number is 11, electronic configuration, it is 2, 8, 1. In the outermost orbit, there is only 1 electron. Then to attain the stability, it will lose 1 electron. 1 electron in a kalakammudu. Look here. When it loses 1 electron, then how many electrons will be there in the outermost orbit?
No
8
electron.
8, sir.
8
8
electrons
electron.
is stable. Then you can write 2, 8. As it loses 1 electron, it gets charged. And we call this charged atom as ion. And if an atom loses the electron to attain the stability, then we call it as cation, nothing but positively charged atom called cation, and is denoted as plus. 1 electron, that is why I have written Na plus. Understood? Come across chlorine. Please write with me. Chlorine, its atomic number is 2, 8, 7. See that in the outermost orbit, there are 7 electrons. To attain the stability, it needs just 1 electron. Got it? As it needs only 1 electron, it has a capacity to receive the electron. Very simple thing is, if an atom has more than 4 electrons in its outermost orbit, then it will receive the electron. Less than 4 electrons, it will donate the electrons. You know, here, valence electrons, more than 7. So, more than 4. Therefore, it will gain an electron. 1 electron in the receiver. After receiving, it gets charged. It receives 1 electron, and after receiving 1 electron, it becomes stable, and we call that as it is a charged atom. 2, 8, 8. As it receives, we write its charge with the negative sign. We write Pn 1-. So this
Sir, if
negatively
it's
charged atom is called anion. Followed? Whereas when we come across carbon, its atomic number is 6. It has 6 electrons. Okay. 2, 4. In the outermost orbit, there are 4 electrons. To attain the stability, it needs 4 electrons. Then now you tell whether it donates the electrons or receives the electrons.
Donate the electron.
No,
Share the
neither
electrons,
donates
sir.
nor
Or
receives.
receive.
Under such condition, it will go for sharing the electron. It will go for sharing the electrons. On sharing the electrons, it attains the stability. Like it is carbon 2, 8. If an atom attains the stability by sharing the electron, it is also to be represented with the positive sign. As it shares 4 electrons, we write C4 plus. Have you written? Listen. Look here. Here, the number of electrons an atom loses or gains or shares will give us information about its stability, and we call this stability of an atom as valency. Followed. Then how do you go for defining valency? Anybody want to define valency?
Combining capacity of an
Element.
Combining capacity of an atom of the element. The combining capacity, and it may combine with other atom by losing the electrons or gaining the electrons or sharing the electrons. So we call that combining capacity as valency. Clear? Okay. Now, let me write about ions. Right. Ions. This is very important part. Ion is nothing but an electrically charged atom. An electrically charged atom. There are two types of ions. One is positively charged atom called cation, and negatively charged atoms, they are called anions. Right. Let us go for listing them. Right. Positively charged atom is cation. Negatively charged atom is anion. Dear students, look here. First, I go for taking the first element, hydrogen. Observe, hydrogen. We all know that it is the only atom which has no neutron. Hydrogen is the only atom which has no neutron. Please do remember that. And it is the lightest atom among all other atoms. Its atomic number is 1. Number of valence electrons is 1. We know that an atom attains the stability either for having the octet configuration or duplet configuration. So up to first 4 atoms we may consider the duplet configuration. That means there must be 2 electrons in the outermost orbit. Here it has only 1 electron. To attain the stability, it needs 1 electron. So it will neither donate the electron nor receive the electron. Instead, it will go for sharing the electrons. So how many electrons it can share? Only 1 electron. Hence, we consider it as H1 plus hydrogen. Whereas, I go for taking lithium. Lithium atomic number is 3. Electronic configuration is 2, 1. Right? Then,
It is
how many
anions.
electrons? Now you tell whether it loses the electrons or gain the electron.
Loses, sir. Loses, sir.
Electron. How many electrons it can lose the electron? How many electrons it can lose to attain the
1
stability?
electron.
1 electron.
We write Li 1 plus. Next.
1 minus, sir.
Carbon. We know that in carbon, in the outermost orbit, there will be 4 electrons. So it will neither lose the electrons nor gain the electrons. Instead, it will go for sharing the electrons. It can share 4 electrons. Hence, we write C 4 plus. Next, and go for taking nitrogen. Nitrogen, its atomic number is 7. Its electronic configuration 2, 5. There are 5 electrons in the outermost orbit. With more than 4 electrons in it.
Sir, it
More than
gains
4
2.
electrons in it.
Gains
It
3,
can
sir.
increase the electron.
3 plus.
Very good. Not 3 plus. 3
3
minus.
minus. 3 minus, sir.
Wait. It can receive 3 electrons to attain the stability. Hence, we can write it is N3 minus. Please do remember. Whereas oxygen, its atomic number is 8. Electronic configuration is 2, 6. It needs 2 electrons for attaining the stability. It is able to receive 2 electrons. Hence we write O
minus.
ನೀವು ಅರ್ಥ ಆಗದೆ ಇದ್ರೆ ಕೇಳಬೇಕು. O2 minus. ಇವೆಲ್ಲ ಕಂಪಲ್ಸರಿ ನೀವು ನೆನಪಿಟ್ಕೊಳ್ಳೇಬೇಕು. ಇಲ್ಲಾಂದ್ರೆ if I go whenever I'll be writing the formula, if you start by hearting, it is not at all possible. Chemical formula should be written based on your understanding. To write that, this will help us a lot. Next, oxygen. Next one is fluorine. 9. Fluorine, its atomic number is 9. Electronic configuration 2,
Loses 1, sir.
7. It needs only 1 electron for attaining the stability. It can receive. So
1
we can write it as F 1 minus.
1 minus.
Next. Whereas sodium atomic number level 2, 8, 1 is the electronic configuration. In the outermost orbit, 1 electron.
1 plus.
Donate.
Donate. 1 plus.
Na 1 plus. Next, magnesium, its atomic number is 12. Electronic configuration 2, 8, 2. It has 2 electrons.
Donate to
Donates.
2 electrons.
Sir, it donate to, sir.
Attain the stability. As it donates, we can write
2 plus.
2 plus. Next, aluminum, its atomic number is 13. Electronic configuration is 2, 8, 3. You can
Donate
also
3.
Sir, it donates.
Al.
attaining the stability. You can write Al 3 plus. Are you all following?
Yes, sir.
Are you all following?
Yes, sir.
Okay. Silicon, it is 14. At electronic configuration 2, 8, 4.
It will share, sir.
Sir, donates.
Sharing.
Share.
4
4.
electrons.
4.
Hence we can write Si 4 plus. Next, after that, 15th one. Phosphorus.
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 2, 8, 5. It can
Sir,
receive the
it gains.
electrons. Receive
1 minus.
3 electrons.
3 gains, sir. It gains 3.
5 electrons in it. There are 5 electrons in the outermost orbit. To attain the stability, it needs just 3. Hence, it can receive 3 electrons. You can write P 3 minus. Next, sulfur. Atomic number is 16. And electronic configuration 2, 8, 6.
It gains
It
2,
gains
sir.
2, sir. It gains 2.
Electrons. How many?
2.
2 electrons. Hence we can write yes 2 minus. Next, chlorine. Atomic number 17.
It will gain 1.
Atomic number 17. Electronic configuration 2, 8, 7.
Sir, it gains 1, sir.
It will gain 1.
1 electron. We can write Cl 1 minus. Next, 18th one, 19th one, which is
Potassium.
potassium. It is 2, 8, 1. So in the outermost
Sir,
orbit,
it donates.
Donates.
1 electron, it donates.
Donates.
Loses 1 electron. Hence we can write it is K 1
1
plus.
plus.
1 plus.
Next, calcium. Atomic number is 20.
It will donate 2 plus.
Donates 2 electron.
Sir, it donates 2 electrons, sir. 2
It can lose 2 electrons for attaining the stability. Hence we can write Ca 2
2
plus.
plus.
Here I'll write Ca 2 plus. Next, other than this, you'll have to remember some of the ions as well. Now I'm going to give you those. Please write. It is Right? Iron. Iron. See, usually we will come to know that metals have a capacity to lose the electrons. Hence, they attain positive charge. In a metal thought, it comes under cation. Iron, it is 2 plus. Next, silver, Ag, 2 plus. Manganese, Mn, 2 plus. Then lead, Pb, 2 plus.
Sir, all metals loses 2 electrons, sir.
Zinc, 2 plus. I don't think so. It depends on the number of electrons in the outermost orbit. One electron is there, it will lose 1 electron. If 2 electrons are there, it will lose 2 electrons. If 3 are there, it will lose 3 electrons. On that basis, we are writing bromine. It can lose only 1 electron. Therefore, sorry, bromine it can receive. Bromine in parallel. Zn 2 plus. Then copper Cu 2 plus. Next, and ammonium NH4 1 plus. It is a compound ion. Compound ion. Last year, just I am making you to recall. Next, whereas ions, other than this, we have some more. It is iodine, I1 minus. See, these are all non-metals. Non-metals, they have a tendency to gain the electrons. Hence, they attain negative charge. Then bromine, Br1 minus. Next, you can also recall some of the compound ions like OH 1 minus. What it is? It is hydroxide ion. Hydroxide ion. You are also very familiar with SO4 2 minus.
Peroxide.
It is not sulfur. Sulfate ion. Sulfate ion. Here I'll write SO3 2 minus. It is sulfide ion. Sulfide ion. Next, I'll write one more. CH3 COO minus. Could you tell what it is?
Glucose.
It is not glucose. It is acetate ion. Acetate. Naming whenever I tell, immediately you may go for writing in the bracket. It is acetate ion. Next, one more. Cr2O7 2 minus. Could you tell what it is? It is
Acetate, how much acetate?
Chromium oxide.
chromate ion. Chromate. Chromate ion. I have been taking the ions only which come under in the very first chapter, chemical reactions and equations. Information. You should not think that how it comes. Immediately you should be able to come to know. Next, other than this, PO4 3 minus. It is phosphate ion. Phosphate ion. Next,
Sir.
NO3 1 minus. It is nitrate ion. Nitrate. Next, NO2 minus. It is nitrite ion. Nitrite. This is nitrate and is nitrite. Next, other than this, here CO3 2 minus. Could you tell what it is? It is carbonate ion. Carbonate. ಲಾಸ್ಟ್ ಇಯರ್ ಕಲ್ತಿರೋದೇ ನಾನು ರಿಕಾಲ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಕಾರ್ಬೋನೇಟ್ ಅಯಾನ್, then HCO3 1 minus. ನೋಡಿ ಇದು CO3 2 minus. This
Bicarbonate, sir. Bicarbonate.
HCO3 1
Bicarbonate.
minus.
Bicarbonate.
Bicarbonate.
Hydrogen carbonate ion or else bicarbonate ion. Bicarbonate ion. Yes. So these are the minimum ions that you must have the knowledge. Got it? Then how these ions will help us? These will help us in forming the compound. Dear students, you all know that if one or more elements combine chemically with a definite proportion by mass, what it is called? ಏನಂತ ಕರಿತೀವಿ ಅದನ್ನ? ನಿಷ್ಕಾ? If two or more elements combine chemically with a definite
Compound.
proportion by mass, it is called compound.
Compound.
Very good. Very good. Compound. If two or more elements combine chemically with a definite proportion by mass, is called a compound. Again, in compound we have classification. We have organic compounds, we have inorganic compounds. Alva, ಈಗ ಅದನ್ನ ಅಷ್ಟೊಂದು ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋದು ಬೇಡ. Just we shall recall the chemical formula of compound. The chemical formula is nothing but symbolic representation of a compound is its chemical formula. You know, it is very simple to write. Just look at them. You can form the compound by taking one cation and one anion. Observe. Afterwards, I'll make you to write. It is hydrogen. This is chlorine. Observe. Hydrogen, its charge is 1 plus. Chlorine, its charge is 1 minus. Then the compound becomes hydrogen chloride, HCl. Hydrogen chloride. Cl1 minus. You don't say that it is chlorine ion. It is chloride. It is nitride. It is oxide. It is fluoride, phosphide, sulfide, chloride, iodide, bromide, hydroxide, sulfate, and rest I have already told you. See, if you go for writing the formula of a chemical compound like this, and we can call it as, it is crossing over charges. We can write the chemical formula of a compound either by crossing over charges or crossing over valencies. Now, I'll go for taking the compound called hydrogen sulfate. See the hydrogen and sulfate. Hydrogen ion is H1 plus. Sulfate ion is sulfate SO4 2 minus. It is here. SO4 2 minus. Crossing over charges. Observe, it is H2 and SO4. Clear up?
H2SO.
Next, I go for taking the compound called aluminum sulfate. Aluminum sulfate. The ions involved are, one is aluminum, second one is sulfate. And the charge of aluminum is Al 3 plus. Sulfate SO4 2 minus. Crossing over charge.
Al2SO4.
SO4 thrice.
Al2, then SO4 thrice. Got it? Hope that you are able to recall the formula how you are writing in 9th standard. ಇದೆಲ್ಲ ಕಂಪಲ್ಸರಿ ಬರೀಲೇಬೇಕು ನೀವು. So now it is time up. In tomorrow's class, we are going to commence actual lesson. And before going to that, just first 10 minutes will be used for writing the chemical formula of compounds. Yakendre, in the chapter chemical reactions and chemical equations, without knowing the formula, we find it difficult to understand the concept and to follow the concepts. So that is why it is much needed to have the knowledge about writing the chemical formula and remembering the chemical formula of the compounds. Got it? And today, what are the basics I have given? Please do practice them today itself. It may be the atoms, atomic symbol, atomic number, electronic configuration, valence electrons, valency, charge. Adishtella, that is compulsory. In today's worksheet, I'll make a chart of that and I'll give you. You are going to fill that chart. It will help you a lot. Got it? Regarding that and regarding cations and anions. Veradu kuda namge tumba important concept. So please do learn without fail and do practice today itself. Okay. With this, shall we stop the class?
Yes, sir. Thank you, sir.
Okay. Thank you very much.
Thank you, sir.
Thank you, sir. Bye,
Thank you,
sir.
sir.